Alright, let's take a look at some problems dealing with linear equations now. This one says a book club had 15 members when it was started. The equation 5m plus 15 equals 35 can be used to find how many months it took the club to reach 35 members. Which of the following is the best interpretation of the number 5 in this context? So we can see that this equation here is written in slope-intercept form. Y equals, it's sort of backwards, right? But y equals m x plus b. Actually, you know what? Let me annotate this so that you can see it better. So, we have this problem. We have the equation 5m plus 15 equals 35, right? 5m plus 15 equals 35. What I'm going to do is I'm just going to rearrange this equation. I'm going to write it as this. 35 equals 5m plus 15. So you can hopefully see now better that this is written in the form y equals mx plus b, although it is a little bit, strange because in this case, we're actually using m as our independent variable, right? You can see that x is aligning with m. M is our independent variable, even though generally we use m to represent the slope in the slope-intercept form equation. It can also be used to represent the independent variable. So in this equation, don't think of m as the slope. Think of it as the actual independent variable, right? Your coefficient of your independent variable, which is 5 in this case, that's going to be your actual slope value, all right? So we can see that 5 is our slope and 15 is our y-intercept, all right? Now that we know that, right, if we go back to our question, it says that it had 15 members when it was started, and the equation 5m plus 15 equals 35 can be used to find out how many months it took the club to reach 35 members. Which of the following is the best interpretation of the number 5 in this context? What's asking us for, what is the interpretation of the number 5 in this context? That would be the slope or the rate of change, right? So now that we know that 5 represents our rate of change, if we go back to our question, it says that m, or independent variable, represents the number of months, and I'm assuming that our dependent variable, or y or whatever it is the number of members, right? And it makes sense because as the number of months go on, the number of members increases, right? So if m represents the number of months and 5 is our rate of change, and uh y is our number of members, then we can say that uh let's go back here for a sec. Actually, we can say that if our slope is 5 over 1, 5 over 1, 5 members over 1 month, right? Because again, m represents the number of months, and y represents the number of members, right? And this is change in y over change in x. So we can say that every 1 month that goes by, the club increases by 5 members. I think that would be a reasonable way to interpret the slope. So let's look at our answer choices. A says the number of months it took the club to gain 5 new members. No, because again, it's saying that every month the club gains 5 new members, not whatever this is saying, right? B says the number of members that join per month. Yeah, I think that makes sense. That's reasonable, right? Because we said that 5 represents, every 1 month the club increases by 5 members. So I think that this one makes sense. C says the number of members in a club when it was 1 month old. No, that would just be you plug in m equals 1 and you solve, right? D says the average number of months it takes similar clubs to reach 35 members. No, that doesn't really make sense at all in this problem. So I think we'll stick with B. And we can see that that's correct. There's not really a way to solve this question using Desmos because it's like interpreting a linear equation. There's not much that you can, use Desmos to solve this question. Okay, let's go to the next one. This one says, Maria used a pump to drain water from a swimming pool at a constant rate. The pool contained 18,000 gallons of water when Maria began using the pump. After 4 hours of using the pump, 14,400 gallons of water remained in the pool. If the pump continues to remove water at this rate, what is the total number of hours Maria will have been using the pump when 7,200 gallons of water remain in the pool? Okay, this one is a little bit more complex. We need to really think about this one. It's saying that first of all, we can see that she's draining water from the pool at a constant rate. So that's our tip off that if the rate is constant, if the rate of change is constant, then that means that we're dealing with a linear equation. Let's look at what information we're giving. It says that the pool contained 18,000 gallons of water when she began using it. Remember how we said that the initial amount typically corresponds with the y-intercept, right? So if it's saying that it contained 18,000 gallons of water at the beginning, then we can say the y-intercept, or b, is equal to 18,000. Okay, and after 4 hours of using the pump, 14,400 gallons of water remained. So after 4 hours, we have this much water remaining in the pool. Okay, and the question is saying if it continues to remove water at this rate, what is the total number of hours Maria will have been using the pump when 7,200 gallons of water remain in the pool? Okay, so to solve for this value, we first need to actually have an equation representing the situation. So I'm going to say that x is the number of hours and y is the gallons of water remaining. Okay, so now that we've defined those variables, if we go back to our information, they said that at the beginning, when she began using the pump, the pool had 18,000 gallons of water, right? Now, although that is our y-intercept, I can also get a point from that. I can say that this is a point 0, comma 18,000, right? Because again, x represents the number of hours since she started using the pump. So when x equals 0, in other words, when she just started using it, there's 18,000 gallons of water remaining, right? And I can also get a point from this information when it says that after 4 hours there's 14,400 gallons remaining. I can convert that to a point. I can say that this is a point 4, comma 14,400, right? Because again, after 4 hours of using the pump, there's this many gallons remaining. And I'll remove the comma here so that we don't get confused. Yeah, after 4 hours, there's 14,400 gallons remaining. So now I have 2 points, and one of those points is a y-intercept, which is really all I need to write an equation for this situation. I can use slope-intercept form, y equals mx plus b. I'll solve for the slope by taking these 2 points, right? I'll do y2 minus y1. Let's call this one I'll call this point x1 comma y1, and this point x2 comma y2. So y2 minus y1 is 18,000 minus 14,400. And x2 minus x1 is going to be 0 minus 4, right? So if I do this math, let's see. 18,000 minus 14,400 is going to be 3,600 over negative 4. And we can see that our slope is going to end up being negative, which makes sense because our rate of change should be negative, right? The number of gallons remaining in the pool should be going down as the number of hours increases, right? So 3,600 over negative 4 is going to be negative 900, or we could say negative 900 over 1, right? And again, there's a couple interpretations that you could use. You could either say that this is equal to negative 900 over 1, or you could say that it's 900 over negative 1, right? Either one of these is technically true, although in this case, only one of them really makes sense, and you'll see why. This interpretation is saying that for every 1 hour that goes by, the number of gallons of water in the pool remaining goes down by 900. That makes sense, right? However, for this one, if it's 900 over negative 1, then you're saying that for every 1 hour of time that we go backward in time, right? Because if x represents the number of hours and x decreases by 1, it's sort of like saying we're going back in time by 1 hour, right? For every 1 hour that we go back in time, the number of gallons of water in the pool increases by 900. That doesn't really make sense in this situation, right? So, I mean, if we were asked to interpret the slope in this context, normally we could say that either one of these works, but in this specific context, it doesn't make sense because time is not really, like, time can't go backward, time can't be negative, right? So I would really only stick with this interpretation that after every hour, the number of gallons in the pool decreases by 900. But back to the problem. The problem isn't asking about slope interpretation. The problem is asking to find what is the total number of hours Maria will have been using the pump when 7,200 gallons of water remain in the pool. So let's actually focus on that. We can see that our slope is negative 900 of 1 over, or negative 900, right? And our y-intercept, we're told, is 0, 18,000. So I can write my equation in slope-intercept form. I get y equals negative 900 x plus 18,000. And I could also write this in point slope form if I wanted. All I would need to do is, actually, you know what, I'll do that real quick. Y minus y1 equals m times x minus x1. You really have to decide which type of equation is, easier to write. All of them will work the same, but a lot of times slope-intercept form is easier to write. But let's say I could use either 0, 18,000 or 4, 14,400 for my point. I'll go with this. Why not? I'll write y minus 14,400 equals negative 900 times x minus, our x value was 4, so x minus 4. That would be my equation in point slope form. But for this problem, I think I'm going to stick with slope intercept form. However, we're still not done. The question isn't asking us to write an equation. It's asking what is the total number of hours Maria will have been using the pump when 7,200 gallons of water remain in the pool. Okay, so remember that the number of hours Maria has been using the pump, that's our independent variable, our x value. So in this case, and the number of gallons remaining in the pool is our y value, right? So in this case, we're actually not being asked to solve for our y value. We're being asked to solve for our x value, right? So I'll plug in 7,200 gallons of water for y, and I'll solve for x, right? So when 7,200 gallons of water remain, we want to know, how many hours have passed. And to find the number of hours that will have passed when 7,200 gallons of water remain, I'll just have to solve this equation for x. So I'm going to start off by subtracting both sides by 18,000. And when I do that, let's see, that's going to give me negative 10,800 equals negative 900x. And now what I'll do is I'll divide both sides by negative 900 to isolate my x variable. And when I do that, let's see, I get 12. So x equals 12. In other words, after 12 hours, there will be 7,200 gallons of water remaining. So that would be my answer. Now, if we go back to the problem, we can see that, this should be my answer. And we can see that that's correct. That was kind of tricky. By the way, there is also a way to solve this question using Desmos. You still have to do, some interpretation. You still need to know how to interpret this problem. But once you can tell, once you get those data points, once you can find that at 0 hours there's 18,000 gallons left, and at 4 hours there's 14,400 gallons left, what you can do is use these 2 points and plug them into a table in Desmos, and then create a linear regression, and Desmos will do the manual work for you, and it'll find for you that it'll find the coefficients of the linear equation for you. So what we do is we put in the 2 points that we identified, 0, 18,000 and 4, 14,400, and then you plot this linear regression. So what happens is Desmos will give you that, if you have linear regression in the form ax plus b, then your a value is going to be negative 900 and your b value is going to be 18,000. In other words, your equation is going to be y equals negative 900x plus 18,000. So this is, the entire equation that we spent so long trying to find, right? Desmos finds that for you. And then Desmos will also give you, once you plug in y equals 7,200, Desmos will automatically solve for the x value. So if I zoom out a little bit, you can see that when y equals 7,200, x equals 12, right? Because this is a line x equals 12. So x must equal 12 when y equals 7,200. So you still do need to know how to interpret these linear equations, and then you can sort of make the rest of the work easier on yourself by using Desmos. So that's also one way that you can do it. Alright, let's look at this last problem for linear equations. It says a bakery makes 12-inch, 8-inch, and 6-inch pizzas. During a certain day, the number of 12-inch pizzas that the bakery makes is 3 times the number P of 8-inch pizzas, and the number of 6-inch pizzas is 18. During this day, the bakery makes 86 pizzas total. Which equation represents this situation? Okay, so we can see that the number of, let's sort of analyze this, right? The number of 12-inch pizzas is 3 times the number P of 8-inch pizzas. So it's saying that the number of 8-inch pizzas is P, right? So let me write that down. I can say that the number of 8-inch pizzas is P. And we can also see that the number of 12-inch pizzas is 3 times the number P of 8-inch pizzas. So 12-inch pizzas should be 3 times P, or 3 times the number of 8-inch pizzas, and the number of 6-inch pizzas is constant, it's just 18, right? So 6-inch pizzas is just 18. Okay, and it's saying that during this day the bakery makes 86 pizzas total. So in other words, if I add up the number of 12-inch plus the number of 8-inch plus the number of 6-inch pizzas, I get 86 pizzas total. So I can say that 3P, which is the number of 12-inch, plus P, which is the number of 8-inch, plus 18 is equal to 86, right? That's the total number of pizzas. If I simplify this a little bit, I get 4P plus 18 equals 86, right? So that would be my equation representing this situation. 4P plus 18 equals 86. And if I go to the answer choices, I can see that that's answer choice D, and that's correct.